Alright, hello class. Today we are going to be doing 1.2, measuring and constructing segments. We're going to skip the warm-up for today just because let's get to the lesson. I want to make it a little bit shorter than the other one. So what we're doing today is students will be using the ruler postulate. We will be copying segments and comparing segments for congruence, and we will also use the segment addition postulate. So I used the word postulate twice already. Let's just define it so we know what it means. It's a rule that is accepted without any proof. Crazy, right? So I'm going to put proof here. Okay. So the first postulate is a ruler postulate. Okay. So basically it's the distance between 2 points. And then whatever one you use, if you start with point A or point B, you're going to do the absolute value. We know when we take the absolute value, we're always going to get a positive answer, but it's just the distance between 2 points. That's all we're using, okay? So if we look, first one, we're just going to find the length of each line segment. The first one is S. I'm going to just put S here is at 2 centimeters. Okay, and then point T is at, if we look, 1, 2, 3, 4. So 4, so we're at 5.4. Okay. I personally always do biggest to smallest, so what we're doing is just subtracting them to see the distance between them. So 5.4 minus 2 gives us 3.4. So since it's a line segment, remember from the previous lesson, we have to make a line on top, no arrows, and it's going to be 3.4, and we have centimeters. So our unit, okay? Same thing we're doing over here. We have unit, or point C is at 0, point D is at 1.1234, is that 4? So I have at 1.4, and then I'm just going to subtract them again to find the distance between them. So I have is 1.4 minus 0, just to keep it, we have 1.4. So our segment is going to be segment CD, its length, 1.4 inches. We use whatever unit is given to us. Okay? First one, not so bad. Let's go to the next slide. Okay? This one says, I'll move that over for you guys, sorry about that. This one says you have to try it, so you guys try it on your own. I'll pause it and wait for you guys to finish it. Okay? All right. Well, now that we're back, I hope that you guys finished the problem already. Well, I'm going to just show you how I did it, and we can compare our answers. Okay, so it's C. C is, oh, lordy. Why aren't you putting? Okay. C is at 0. D is at, what is it? 1, 2, 3, 4, 5. 3.5. You could just subtract them if you want. Remember, it always has to be a positive answer since distance is positive. So I did is segment CD is 3.5 centimeters. Okay, lovely. All right, let's go to congruence. Okay, so line segments that have the same length are called congruent segments. You can say that the length AB is equal to the length CD, or you can say AB is congruent to CD. Okay? Congruence usually talks about relationships, and length is just saying that they're equal. Okay? So over here, we're going to just plot these points. So this is example 2. We're plotting the 4 points on the coordinate plane, and we're going to determine whether line segment JK is congruent to LM. Okay, so I have is J is -3, 4. Remember, we always do our X and then our Y values. So I'm going over -3 up 4. Okay, I'm going to put J. And the other one I have is K is 2 +4. This is K. I'm going to just connect them to make them one whole line. and then I'll use a different color. Do that one. Okay, the next one we have is L, which is 1. So I'm going to the right one, up 3. And then M, which is 1, -2. Okay, this is L, this is M. Oops. Okay, so J, K, the distance between them, all you're doing is counting boxes. So 1, 2, 3, 4, 5. 5, and then LM, count down, 1, 2, 3, 4, 5. 5. If you look, they are equal, so therefore we can say they are congruent. So I have JK is congruent to LM. That little squiggly tells us congruent. Equal signs say that they are equal. I'm going to put, again, since the line segment, forgot to do that up there. Sorry, guys. That's all we have to do. Okay, moving on. Next one. Same thing. We're going to plot the points A, B, C, D in the coordinate plane and then determine if AB is congruent to CD. Okay. So I have, again, I have is A is -2, up 4. A. I have is 3, 4 up here. B, so AB. Find the distance first. We'll just do it a little bit differently. Again, we're counting 1, 2, 3, 4, 5. Okay, and now we just have to plot CD. Change the color for you guys. Okay, so CD I have is 0, 2. It's right here. So I'm not moving left or right anything because my X in this case is 0, no movement. Over here I have 0, -2. 0, -2, count. Label, I have C, D. I'm just counting 1, 2, 3, 4. So I have CD is 4. If you look, they're not the same numbers, therefore they cannot be congruent. So I have AB is not congruent to CD. Okay. Moving down. This is your try problem. Please try this on your own. I'll pause the video and then we'll come back and we'll go over it. Okay. All right. So again, it says to plot A, B, C, D and to tell whether they are congruent. A, B, and C, D. Okay. So I'm plotting them. I'm doing A. I have as A is -5, up 5. A here. I have as B is -2, up 5. B, connect them. A, B, the distance between them is 3. You just count. Not crayon, pen, and I'll do blue this time. Okay, we have a C. C is going to be +2, down 4. Okay, and then I have is -1, down 4. This is D, this is C, and we're just putting them together. So we count 1, 2, 3. CD is 3. They're both the same numbers. That means their lengths are the same. We're saying that the AB is congruent to CD. Lovely. All right, guys. Not so bad so far. All right. All right, guys. So now we're going to be using the segment addition postulate, which means is when 3 points are collinear, you can say that 1 point is in between. Oh, between. Oh, whoops. Between 2 other points. Okay, so if you look over here, B is in between A and C. Okay, D and F. E is not in between them because it's not in the same line. They're not collinear. Okay, so this is the other postulate that we have, which is a segment addition postulate. So if a point is in between, so in this case B is in between A and C, we can say that A and B plus B and C is the whole thing AC. Okay, that's what we're using. So if it says find, it wants to find the whole thing, X, oh God, XC. Okay, so if you look, we have this piece, and we want the whole thing. So we're just going to add them together. So I have xy plus yz equals xz. Okay, so this part right here is 23. 23 plus 50 equals, just add them together in your calculator, you would get is 73. We don't put units with this just because if you look, there is no units. So I'm just going to write xz, line segment again, equals 73. Because remember, it's endpoint to endpoint. Okay, next one. If you look over here, we have a part of it. We don't have this part. We have the whole thing. So there's two ways you can do it. You can look at it and you can say, all right, well, if I have this piece, I'm missing this piece. In order to get that, I can subtract them, which is probably the best way. Or you can make it an equation, which I don't have my x here. So this is what I'm missing. I know if I add them together, I'll get 36, and it'll be the same thing. So what I'm going to do is 21 plus x equals 36. Okay, because I'm missing this piece. I want to find it. I'm going to subtract 21 to both sides. I get x equals 15. Okay, so that means GH is going to be 15. Okay. You have a try problem. So I'll let you guys do that. So you pause the video. All right, welcome back. Let's do this. So if we look over here, we're trying to find the whole segment. So I have as D, E, and F, the whole thing. So I have this piece and this piece. I'm just going to add them together to get DF. So I have as 23 plus 35 gives me 58. So I have DF equals 58. Okay. Over here, the same thing. I have this whole piece. I'm missing my KL, and that's what I want to find. And I have JK. So remember we did before where I did the missing piece with the X. You can still do that if you know, and you can look and say this is the whole thing. If I take this away, I'll find this piece. You could just do that. So I'm going to do 144 minus 37. Okay. Okay. You're going to get is 107. All right. So KL is 107. All right, we're in the last example, and we are done. It's exciting. Okay, so example 5. The cities shown on the map lie approximately on a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. We have Tulsa right here to St. Louis. Okay, so if you look, we don't have this piece. They give you Lubbock's and the whole thing. So again, it's kind of like the previous problem we just did. You do whole minus one of your pieces to get the missing piece. So we do 738 minus 377. Okay. Okay. When you subtract them, you should get is 361. All right, but remember we're talking about is miles, so we have to put units with it. So I'm going to do miles here, and then we're good, guys. All right. So what you guys have to do is, after this, you're going to do the exit ticket, which is on the same slide as this video, and then after that, just your homework. Remember, you have to upload your homework as a PDF and upload it to Google Classroom, and make sure you press submit. All right, guys, have a nice day. Bye.